let's find the bounded area first. So we have a cosine of x. Okay, so the cosine of x from 0 to pi over 2 looks like that. This is pi, so 0 to pi looks like that. And 1 minus cosine of x. So that 1 does a vertical shift. Okay, and it's starting from the bottom. Okay, so typically from, let's say this is 1, 0 to 2. So typically it will look like this. If it was 1 plus cosine of x, but it's 1 minus, so it looks like this instead. Okay, like that. We're talking about from 0 to pi. So you can see we're talking about this area here and this area. Okay, so how do you set this up? We first need to find their intersection point. Okay, for that, you make these two equal to each other. Okay, so bring the cosine x over, you get 2 cosine of x equals 1, so cosine of x equals half, so x is equal to, right, pi over 3. So this is pi over 3. So we have to integrate from 0 to pi over 3, and then pi over 3 to pi. So from 0 to pi over 3, you can see that the cosine curve is on the top. This is on the top. So cosine of x minus, this is on the bottom. So 1 minus cosine of x plus here 1 minus cosine of x is on the top. So we have 1 minus cosine of x and then minus cosine of x. Okay, let's clean that up and then find the antiderivative, and we're going to have the area. So we have cosine of x, we have 2. Okay, so we have 2 cosine of x minus 1 . Okay, we have 1 minus 2 cosine of x. Okay, the antiderivative of that is going to be 2 sine of x minus x. Okay, and here is going to be x minus 2 sine of x. Okay, so let's plug in pi over 3. Sine of pi over 3 is root 3 over 2 minus pi over 3. Plug in 0, it's going to all turn into 0. Plug in pi, we have pi, sine pi is 0, so sine pi minus 0 minus, now pi over 3 minus 2 times sine of pi over 3. So sine of 60 degrees, that's root 3 over 2. Okay, so we get a root 3 minus pi over 3 plus pi, okay, minus pi over 3 plus root 3. Okay, so add those two and you get 2 root 3. You have 1 pi and 2 of pi over 3. So you're going to get just a pi over 3 when you find the difference. So that's the answer.